Yesterday we practiced graphing systems of linear inequalities. Today I'm going to be giving you the graph and saying, please write down these equations. We actually learned how to do this in Chapter 5 as well, but now we're just going to be writing two different equations in the same problem. The first step is going to be to identify the slope and the y-intercept. Now, just as a reminder, the slope is going to be rise over run, and the y-intercept is going to be the place on the graph where the line crosses the y-axis. After you've identified the slope and the y-intercept, you're going to set up your equation, and you're going to use a greater than when the shading is above, or a less than when the shaded part is below. Then you need to decide whether or not you need an equal to. You use an equal to, it's a little hard to see, let's try a different color. You use an equal to when it's a solid line, and you leave it without an equal to when it's a dotted line. Last but not least, don't forget about Vuxoy. For vertical and horizontal lines. So, let's try an example where there is only one line graphed in the problem. So shading above or below, above, you're going to use a greater than. Below, you're going to use a less than. If it's a solid line versus a dotted line, if it's solid, you're going to use an equal to. If it's dotted, you're not going to use an equal to, just as a quick, brief reminder. For example, in this problem, I'm going to need to start by finding my slope and my y-intercept. Now, I would suggest finding the y-intercept first. I think that's always easiest, which would be -4. To find my slope, I need to find another perfect value that my line goes through. So I see another one up here. If I count, my rise would be 9 and my run would be 2. So I would have 9 over 2. Now I would set up my problem. Y, and then a space, 9 over 2x minus 4. Don't forget the x. That is something that a lot of students lose points for, is forgetting to put the x there. I think they're so excited about filling in the numbers that they forget the actual x. Now the shaded part here is below. So I would make my symbol a less than, and it's a dotted line, so I do not need an equal to, which means this would be my final answer. What we're going to be doing today is that exact same process, only we're going to be doing that when there's more than one line in the graph. So step 1 is going to be decide which line you want to do first. The first line I would do in this problem is this diagonal line. So I'm going to make that line darker and purple. And inequality number 1 here is going to be the purple one. So for the purple line, the slope and the y-intercept is the first information I need. The y-intercept here would be, let's see here, it crosses at the 1. And the slope would be up 2 over 1, which is 2. So I would fill in y and then 2x plus 1. Now for my symbol, it's a solid line and the shaded part is above the line. So I would make it a greater than and an equal to because it's above and it's solid. Now the second line here in this problem is a little bit tricky to see. And the reason I say that is because it's right on top of one of the grid lines. I can tell there's a second line here because my shaded part just kind of stops. So that's got to be one of my other border lines. Now for the green line, I'm noticing that it's horizontal. So I'm going to think about Vuxhoy. For horizontal lines, I know I use the letter Y. And this line is located at +3. Because the shaded area is above this line, I would make it a greater than. And because it is a solid line, I would make it an equal to. All right, let's try another problem. Let's try problem 2. Again, let's first start by just identifying which lines we're trying to work with here. The first line I'm going to work with is this purple line. I can tell there should be a line there because that's where my shaded region just kind of stops. So for my purple line, I'm going to need to remember Vuxhoy because it's a vertical line. If it's a vertical line, I know I use the letter X, and it crosses the axis at 2. So I'm going to make it X and then space and then 2. Now the shaded part of this graph is to the left, so I'm going to make it a less than, and it is a solid line, so I'm going to make it an equal to. My other line in this graph would be this line right here. And the reason I know that that's the other line is, again, my shaded region just kind of stops. That's one of the edges. Again, I'm going to remember Vuxhoy. This time it's a horizontal line, so I'm going to use the letter Y. It crosses at 4. The shaded part of the graph is below, so I would make it a less than, and it is solid, so I would make it an equal to. Let's try a few more examples. For number 3, we have 2 different graphs going on here. The first one that I'm going to work on is the solid line in this picture. So I'm going to have this solid line right here. For the purple line, I'm going to need to know the slope and the y-intercept. The y-intercept is easy, it's just -3. The slope, I'm going to count the spaces between the place where the line intersects and the y-intercept. It's always a good idea to use the intersection point as one of the dots for your slope. So I would rise 2, run 3, so 2/3. I'm going to put the y and then a space and then 2/3x minus 3. Now the shaded part of the graph is below this line. So I'm going to put a less than, and it's solid, so I'm going to put an equal to. Now let's work on the green line. I'm going to make the green line my dotted line here. The y-intercept and the slope of this line, the y-intercept is 1. The slope would be down 2, right 1, so -2/3. I'm going to put the y and then a space, and then -2/3x plus 1. Now the shaded part of the graph is below this line, and it's not solid, so I would leave it as just a less than, and I'm done. We're going to save examples 4, 5, and 6 in case we need to go over some more examples tomorrow in class, but I hope that this makes sense, that you just sort of look at the 2 lines separately and write each inequality separately. We will practice this tomorrow. Thank you so much for watching, and I will see you then.